Welcome to the sponsored edition of the Light Reading Podcast. This is Phil Harvey. Joining me today on the podcast are the president and CEO of Tensor Networks, Alexis Flores-Betancourt, and the chief technology officer of Tensor, that's Bill Walker, formerly of CenturyLink. And Tensor Networks is a software and hardware company. They're a startup, and they are really taking on a space that generically we can call next generation network computing. So in this podcast, you'll get to know what they're building, what kind of company they want to be, what their aspirations are as a company, how they fit into the networking space versus the incumbents in that area. And there's some giant companies in that space. And then specifically what edge they think they have when it comes to dealing with solutions for both enterprises and for network operators. So stay tuned. You have a lot to learn about Tensor Networks right after the break. Welcome to the Light Reading Podcast, the sponsored edition of the Light Reading Podcast. And today we are talking to and about Tensor Networks. I'm Phil Harvey, and joining me on the podcast today is the CEO of Tensor Networks, Alexis Flores-Betancourt, and the chief technology officer of Tensor Networks, Bill Walker. Thanks for being on the podcast. So I guess the most obvious place for us to start is to get into a description of the company, who you are and what you're all about. So let's start there. Who is Tensor Networks?
Hi, again, my name is Alexis, and Tensor started back in July of 2019, so we're almost a year old. We started as a group of just talented people, really, that were disillusioned with the progress being made in Tier 1 carriers and the hyperscale players who own that customer edge and computing edge of service delivery. And, at the end of the day, we want to transform what it really means to be, a networking and high-performance computing company, that convergence that, we want to transform the way service delivery works. And we've watched carriers struggle for about a decade to build NFV infrastructure and service management platforms that can deliver new services and self-provisioning. We have watched AI and ML along with machine learning stay in that science category and never really reach the potential of consumerization and delivering the promise of life-changing value to society. And, especially now in this time, it's where it's really needed. And so at the end of the day, we are a hardware and software company, but we're, leading more into that software side because that's where we're going. That high, performance computing everywhere, but we're also, making sure that the network side of it is there.
Okay. So just to back up a bit, it's a hardware and software company, leaning toward the software side. So obviously you have to start out delivering it on something and then eventually you'll get into more of the software. But the whole focus is not just in the connectivity part, but really in service delivery. So that implies that there's a little bit more intelligence going on in the background. So what does the company aim to deliver to its customers? And just so I'm clear, who are those customers?
So the hardware really started as kind of a modular. We wanted to keep it open. We're a member of Linux Foundation, Intel Network Builders. We look at the reference designs, and I don't think there's anything to be done really super sexy in servers. You bend sheet metal, and you put Intel chips in it, and then you add a GPU board and some network cards. So, trying to deliver an innovation in that area is really kind of useless at this point. I mean, this has been 30 years of the same hardware. So having the right combination of those modular pieces of CPU and processing and memory and GPUs and network and building profiles of those hardware platforms that support different use cases. So NFV or AI and ML. Well, when we looked at it, we said, well, why can't AI and ML be used to help manage network traffic? Well, if I'm doing that, I run better if I have GPUs in the box. So I'll put GPUs in the box. Now I can accelerate networking with GPUs. So I start to tie the smart NICs from, Intel, the QAT software, Mellanox and their smart NICs, all the fancy stuff that they do on FPGAs and the ASICs on those boards. And if I can tie that into GPUs to actually do a lot of the processing and compression and encryption, then I can minimize the impact on the x86 chip. And the x86 chip can run real software instead of just picking up packets from a network card. So when I first built our first box, the Matrix Edge, to install the software took me a day and a half because I had to install Open vSwitch, and then I wanted the free range router, and then I configuring containers and virtual machines. And I had that down to 8 minutes. I realized that like 80 to 90% of the software solves the use cases for AI and machine learning, video transcoding, Industry 4.0, collecting all that data from sensors, and even things like video surveillance and facial recognition. Having all of the same libraries and the same profiles, I can create personalities of a machine that consume those underlying resources. So there's no reason to start with a generic Red Hat or CentOS or Ubuntu install DVD and then spend a day and a half configuring it. So having these personalities of the machine allows the end user to say, I'm a video processor with AI and ML to do facial recognition. And those components load in together and save the customer that configuration step and that long engineering process of a new solution. Take
a look at the hybrid cloud, for larger enterprises. We're looking at billions of data points, right? I mean, not just from me even, we all have a phone of sorts. And imagine all these other companies, right? What they're delivering, what their services and such. And there comes a point where everyone starts to lose, a bit of a control of their expanding and overly complex networks. And so, we're trying to change that to make it simpler. Going from a day and a half to, just get something set up to 8 minutes is really huge. And, we want to make networks and network efficiency a key component of service delivery.
This is more than just you're delivering a package that can help out network operators with high performance computing and networking. You're also giving them the tools to deliver services at the edge, maybe at a different price point than what they're doing now.
Exactly. Everything comes down to a cost per bit, cost per movie, cost per transaction.
Right.
And, step one is, can we add 20, 30, 50% more throughput out of the same box or the same price point box? But then step two is, and can I make it future proof that they can add services, add capabilities, and modularly upgrade the systems and software as they go? So it becomes an evolving platform instead of a forklift upgrade.
Okay. Now, was I right in assuming that that your end customer is going to be the network service provider, or might that be a much broader swath of companies? Because high performance computing at the edge does sound tempting to a lot of different types of companies.
Exactly. And that was my first use case. I mean, obviously coming from a tier one carrier, I thought, I'm going to build an NFV box that solves what I wanted it to solve. And what we discovered is those underlying elements. So if I need 100 GPUs to accelerate my networking and do encryption, there's still 2,400 GPUs on the box that are idle. So I started to look at how can I use those. And Alexis, coming from the data science side, said, I've got 2,500 GPUs. I need 2,000 of them to solve my problem of facial recognition and voice pattern recognition. But here's a couple hundred extra if you can make my network run faster. So between the two of us, we can come up with something that applies AI and ML to the network traffic, as well as accelerating how data gets in and out of the applications, whether those are firewalls or VPN servers or facial recognition software and smart city elements.
Okay. Yeah, Alexis made a good point earlier about the nature of, it just sort of dawned on me. It's like, yeah, she's right. We have been kind of talking about NFV now for about a decade, or maybe more than a decade.
Exactly.
It's like this thing that was supposed to be this massive revolution in the service provider network has arrived painfully slowly. And the market hasn't really waited on it. A lot of what we're seeing are cloud computing companies now just gobbling up critical pieces of telco infrastructure and finding ways to make those cloud native so they can deliver the services.
Exactly. And that answers your question of, are the carriers our primary, customer? And that was our first thought. But the sales cycle and the engineering cycle and the deployment cycle just doesn't make sense, especially for a small company. So we, instead of looking at where do we fit in the chain of hardware, where do we fit in the network, we looked at what problems are we trying to solve. And if we go to Smart City Industry 4.0, live broadcast video processing, I mean, the existing use cases that we've actually delivered on, it's not about the carriers. It's about what needs a transformation today.
Right. Yeah. And those are some pretty powerful use cases because there are lots of companies trying to get into those spaces. I should ask you about a couple of those. So in the competitive sense, what would set Tensor Networks apart from a company like Cisco or like Dell that's already, solidly in this edge computing space?
So number one, it's mindset. And I kind of realized this a few months ago that we're not taking a computer and trying to put network in it. So if you compare it to a Dell, Lenovo, server company, we're not adding network to a computer and then complaining about the traffic. And we're not a network company that's adding CPUs to a switch. We're looking at it as we need to move data in between things quickly. And those things could be NFV software or video processing, transcoding, or network ports. So how do I move data within the machine more efficiently? So it's not about computing and switching. It's about moving data, moving information around more efficiently.
Okay. So it's a different kind of, you're attacking the problem from a completely different way then.
It's a different mindset.
From a competitive standpoint also, I mean, Alexis, what's the sort of the pitch to companies that are looking to, that are maybe weighing, your solution versus an incumbent, like a Cisco or like a Dell?
Well, I think we also have to look at it at a price standpoint, right? For one, okay, so we're, it's a hyper-converged solution that's, including compute, storage, and secure networking at layers 1 through 7. And when we talk about, really being different, I mean, it's not just on that, hardware, software side, but it's also looking at price. Just to give you an example, take a look at school districts, right? That there's a huge push for education and making it better and all that. And, especially with COVID-19 and how things are going on, I mean, are kids going to go back to school? Are they going to be at home? How's that connection? How's the networking? And, it's not just about, that the infrastructure now. You're talking about, okay, will they have access? Will it be quick? Will it be good? Is it efficient? Where's the price? I mean, where's the to go? Some of these schools don't have as much funding as others, and I really see this in places like Oakland, for example. I was at Berkeley for some time, and I personally worked around those schools, and they don't have even like a parking lot for their teachers, and it's because you see them have to spend so much money on these routers, right, for just the networking connection, that they can't even afford to really, hire more teachers or provide the schools, just better structure in that physical sense. And so there's, again, that the part that Bill talked about, but there's also that price. I'm a huge advocate for education and, the closing that opportunity gap, and it's hard all around. And in this time where kids might not be able to go physically to school, how do you change that? How do you make that better?
If you're talking about a school system that already has trouble affording books, and then you're telling them, oh, by the way, let's do all of this online, get your kids some tablets, etc. It's like, well, that's asking a bit much.
Exactly. And how many schools actually have 10 gig?
Right.
I mean, that around here they do, but it's difficult if you get out into rural America. All of a sudden you've got these different profiles.
Yeah.
Everybody needs a VPN server. Everybody needs the firewall. So that 80%, 90% solution means that I can take a bank branch office solution stack and turn it into a education stack
Okay.
in a week instead of 3 years.
Right. So a lot more. So the different price point, a lot of flexibility.
Less engineering, lower cost per teacher, lower cost per student.
And that's just one example. I mean, another thing, is that we are open source, open architecture. And if, you're a company that needs more GPU power, okay, let's add another one in there,
Right.
And for another company, for example, like you mentioned Dell, if you're like, hey, well, how about you add this or maybe take out that? Or, I mean, they're going to tell you no, most likely, right? Like that would take a lot on their part. And so we're like, okay, well, let's be adaptable, right? Reliable and adaptable. And I think that's a key point for us. You don't just need hardware. It needs to be not only efficient and reliable, but it should have modularity and adaptability.
Okay. And you've already addressed this, but I guess my final question would be in the whole, looking at the whole of networking. So every time you hear about, and this is kind of a traditional networking thing, especially as it goes to telecom, but every time you hear about something that's a expressly unique solution, that's almost industry code for, and you must buy only our stuff because it's proprietary and you can't get out of it. Are you, is the play here to get in the door with a proprietary solution and sort of lock yourself in place?
So from hardware and software perspective, that's been goal number one, is that all the hardware is based on standard industry components. Somebody could copy it tomorrow. And the software is 99.999% open source. And we will be contributing back everything that we do to the communities. The idea is to own the customer through innovation and thought leadership rather than locking them in.
Right.
There's nothing that stops anyone else from doing exactly what I did with Matrix OS, downloading the latest Ubuntu or Red Hat DVD off the internet and making it special. I have written less than 4,000 lines of code total to turn a generic consumer Linux OS distribution into what we deliver. We welcome others to cooperate and make it better for us.
You said so completely open on the hardware side, completely open on the software side, or at least with a little bit of an innovation edge, and then you contribute back once you harden a feature, I guess.
Rule number one: we're not the smartest people in the room.
Right. Well, I live by that. I get. I certainly appreciate that rule. And so does this go to market via direct sales or via channel at first? How are you guys sort of approaching it?
Well, it's going to be available for download off our website July 1st.
Okay. Couldn't get more direct than that.
Most of our sales so far have been direct sales, just because we're a small startup and we were stealth. It was all word of mouth.
Yeah.
We are working to establish resellers and box integrators. Dealing with an ODM, we have volume. It's now how much of the work do we want to do versus someone already does it. So let them do it. So companies that do rack and stack and pre-cabling and testing and integration are out there. And obviously they're smarter at doing that than we are. So we leverage the people around us.
All right. Is there anything anything else we need to know about Tensor Networks before people check out your website and look you up?
Well, in my opinion, I think Tensor Networks has really looked, to the future, and really looking at converging everything that has kind of been separate, right? And coming from someone that hasn't had, the 20 plus years, right, in the industry, seeing, okay, well, in order to build this infrastructure, well, I need this, and I need this device, and I need that software, and it's like, look, here's everything that you need. Why don't we just make it easier, right? And like Bill said, leverage what everyone else is doing and just help each other out. At the end of the day, that quote is great. You shouldn't be the smartest person in the room. And I myself lived like that. In college too, it's you're going to learn more from people and from helping each other out than by, always trying to block someone else or close yourself off from other opportunities. So yeah, I think that's really where I see the value in Tensor, and the reason why I was like, okay, let me just change careers here and risk it all and go join a startup. But when I see the potential of it, I mean, it's there.
If you look at the people that are involved, we have one guy who's operations and understands logistics and ODMs and building stuff. We have a data scientist. We have a guy who's an IT guy who lived in the telco industry for 10 years. And if we get together and we say, God, this drives me nuts. I wish this was easier. I wish I could do this. Alexis tells me, configuring a machine with GPUs to do AI and ML is just ridiculously complex. Well, I'm a Linux guy. I can throw that together and make it easier for you. So us trading ideas and then treating our customers the same way, that the customers give us ideas and say, God, but I wish your platform made this easier. Well, that just means I'm going to lock myself in my office for 3 days until I figure out how to do it for them. So allowing other people to give us our requirements and give us our features list just gives us really cool problems to solve.
And that's a good place to leave it. Alexis Flores-Betancourt, thanks so much for being on the podcast. Bill Walker, thank you as well.
Thank you so much.
That is it. That's our show. Thanks so much to Alexis Flores-Betancourt and Bill Walker for their time and insights today. If you need to know more about Tensor Networks, they are TENSOR networks.net. Thanks so much to Tian Fu for producing this episode. If he weren't working so hard, you wouldn't be able to hear any of this. And thank you, dear listener, for paying attention, because if you weren't paying attention, we couldn't get away with doing all this at work. This is a sponsored edition of the Light Reading Podcast. You can find out more about the podcast by going to lightreading.com/LRpod. And we will see you next time on the Light Reading Podcast.